Hello my dear students, welcome back in the chemistry class. Myself Gurinder Pal Singh, hope you all are fit and fine. We will start a very interesting chapter of chemistry, that is surface chemistry. In this chapter you will clearly understand the concepts of absorption and adsorption. We will also discuss about catalysis, solutions and general methods of preparations of sol. We will also study methods of purification of colloidal solutions, properties of colloidal solutions, coagulation of colloidal solutions, protection of colloids, emulsions and gels, and applications of colloids. Before starting this chapter, I would like to give you some brief introduction about the chapter. Students, we know that properties of substances are different at the surfaces and in the bulk because the molecule present in the bulk are equally attracted in all directions, having net force 0. But the molecules present at the surface experience attraction unequally. Due to unbalanced forces, these molecules present at the surface tends to take up molecules of a gas or any other substance in order to release the surface tension which they are experiencing. Students, very important thing that surface is more activated in case of finely divided state or a rough state. And in this unit, we will study phenomenon related to surface. So, students, surface chemistry is the branch of chemistry which deals with the study of nature of surface and the species present on it. This phenomenon is studied with the help of adsorption and colloidal state, which are quite useful to understand the physical and chemical characteristics of the substance. First of all, I'll tell you about adsorption. As we know that surface of a solid has the tendency to attract and retain the molecules of the phase with which it comes in contact. Students, these molecules retain only at the surface and do not go deeper into the bulk. So students, the accumulation of molecular species at the surface rather than in the bulk of solid or liquid is termed adsorption. The molecular species which accumulates at the surface is called adsorbate, and the substance on the surface of which the adsorption occurs is called adsorbent. Students, you must know that adsorption is essentially a surface phenomenon. Solids in finely divided state act as good adsorbent due to large surface area. So my dear students, charcoal, silica gel, alumina gel, clay, colloids, metals in finely divided state, etc. acts as good adsorbents. Now, I'll tell you some examples of adsorption. In very first example, the pressure of gas like oxygen, hydrogen, carbon monoxide, chlorine, ammonia or sulfur dioxide decreases if taken in a closed container containing powdered charcoal due to adsorption of gas on the surface of charcoal. In second example, when animal charcoal is added to the solution of an organic dye, let us say methylene blue, the solution becomes colorless. The reason behind it is it's because of accumulation of molecules of dye on the surface of charcoal. In the next example, aqueous solution of raw sugar becomes colorless on passing over animal charcoal. Last but not the least example of adsorption is in the presence of silica gel, the air becomes dry because water molecules gets adsorbed on the surface of gel. The process of removing an adsorbed substance from a surface on which it is adsorbed is called desorption. Now students, if I'll talk about distinction between adsorption and absorption, then adsorption is a surface phenomenon. But in absorption, the substance which is called adsorbate, that substance is uniformly distributed throughout the bulk of the solid. I will explain this with very good example. Students, listen carefully. When a chalk stick is dipped in ink, the surface retains the color of the ink due to adsorption of colored molecules, while solvent of the ink goes deeper into the stick due to absorption. On breaking the chalk stick, it is found to be white from inside. If it is not clear, then I'll give you next example. In next example, water vapors are absorbed by anhydrous calcium chloride but adsorbed by silica gel. Very important and interesting thing that I would like to tell you, that both adsorption and absorption can take place simultaneously also. The term sorption is used to describe both the processes. Now we will discuss the mechanism of adsorption. Students, surface particles of adsorbent are not in the same environment as the particles inside the bulk, because on the surface the particles are not surrounded by atoms or molecules of their kinds on all sides, so they possess unbalanced attractive forces and responsible for attracting the adsorbate particles on its surface. And one most important thing, during adsorption there is decrease in surface energy which appears as heat, so it is exothermic process. It means delta H is always negative and freedom of movement of adsorbate molecules becomes restricted, means delta S is negative. Now we will study factors affecting adsorption of gases by solids. First is nature and surface area of the adsorbent. Students, greater the surface area of the adsorbent, greater is the volume of gas adsorbed. Therefore, silica gel and charcoal are good adsorbing agents. Second factor is nature of the gas being adsorbed. Students, a gas which is more easily liquefiable or is more soluble in water is more readily adsorbed. And third factor is temperature. Students, on increasing temperature, adsorption of gas decreases because adsorption is exothermic process. And fourth factor is pressure. Adsorption is directly proportional to pressure. It means if pressure increases, adsorption increases. If pressure decreases, then adsorption decreases. Now we will study about the types of adsorption. There are mainly two types of adsorption of gases on solids, that is Physisorption and Chemisorption. In Physisorption, weak Vander Waals forces acting between adsorbate and adsorbent. But in Chemisorption, chemical bonds, means covalent or ionic bonds, are formed between adsorbate and adsorbent. Example, like dihydrogen is first adsorbed on nickel by Vander Waals forces, and molecules of hydrogen then dissociate to form hydrogen atoms which are held on the surface by chemisorption. Let's discuss the characteristics of Physisorption. First characteristic is lack of specificity. As we know that as the Vander Waals forces are universal, so a given surface of adsorbent does not show any preference for a particular gas. Second is nature of adsorbate. Students, in general, easily liquefiable gases are readily adsorbed as Vander Waals forces are stronger near the critical temperatures. Third characteristic is reversible nature. My dear students, adsorption increases with increase in pressure due to decrease in volume of gas, and gas can be removed by decreasing pressure. Fourth characteristic is surface area of adsorbent. Well students, the extent of adsorption increases with increase of surface area of adsorbent. Due to this, finely divided metals and porous substances having large surface areas are good adsorbents. Fifth characteristic is enthalpy of adsorption. Students, in this case, enthalpy of adsorption delta H is negative. It's very low, that is from 20 to 40 kilojoule per mole. It is due to weak attraction, due to weak Vander Waals forces between gas molecules and solid surface. Now we will study the characteristics of chemisorption. First one is high specificity. Students, it is highly specific and occurs only if there is possibility of chemical bond formation between adsorbent and adsorbate. For example, oxygen is adsorbed on metals by virtue of oxide formation, and hydrogen is adsorbed by transition metals due to hydride formation. Second one is irreversibility. My dear students, this is usually irreversible in nature and exothermic process, but the process is very slow at low temperatures due to high energy of activation. Like most chemical changes, adsorption often increases with rise of temperature. Usually high pressure is also favorable for chemical adsorption. Third one is surface area. Similarly, like Physisorption, Chemisorption also increases with increase of surface area of adsorbent. And fourth one is enthalpy of adsorption. Students, enthalpy of adsorption is high, that is 82 to 40 kilojoule per mole, as it involves chemical bond formation. Now, if I'll talk about the comparison of physisorption and chemisorption, then my dear students, as we have discussed, physisorption arises because of Vander Waals forces and chemisorption is caused by chemical bond formation. Physisorption is not specific in nature and chemisorption is highly specific in nature. Physisorption is reversible in nature and chemisorption is irreversible. Physisorption depends on the nature of gas. More easily liquefiable gases are adsorbed easily. Students, chemisorption also depends on the nature of gas. Gases which can react with adsorbent show chemisorption. In physisorption, enthalpy of adsorption is low, that is 20 to 40 kilojoule per mole. And in chemisorption, enthalpy of adsorption is high, that is 80 to 240 kilojoule per mole. Physisorption is favorable at low temperature. It decreases with increase of temperature. And chemisorption is favorable at high temperature. It increases with increase of temperature. In physisorption, no appreciable activation energy is needed. And in chemisorption, high activation energy is sometimes needed. Students, physisorption increases with increase of surface area of adsorbent. And chemisorption also increases with an increase of surface area of adsorbent. These are some questions for you to practice. If you are confused about any question, then you can watch the video again and try to find out the answer of that question. Hope you like this video. Thank you so much, students. Goodbye.